Hello all. Over the past few days we have been solving inequalities. We started with one-step inequalities, then we looked at two-step inequalities, and now we are going to solve multi-step inequalities. So our key concept is I will be able to solve multi-step inequalities. You can write that at the top of your papers. Some things to remember about solving inequalities. You solve inequalities exactly like you would solve an equation. You use those opposite operations. Okay, so the opposite of addition is subtraction, the opposite of multiplication is division, all of that stuff. The one thing that you have to remember is if you multiply or divide both sides of your inequality by a negative number, you have to remember to switch the direction of the inequality symbol. Otherwise, you will not get a true statement. And then, of course, when we're dealing with inequalities, we are always going to graph our solutions on a number line. Okay? Remember that if it's greater than or less than, it's an open circle. And if it's greater than and equal to or less than and equal to, it's a closed circle. So let's look at our first example. I have 3x plus 4x is less than or equal to 21. Well, 3x and 4x are like terms, so I know that if I've got the same variable raised to the same power, I can combine those into one term. So 3x's plus 4x's gives me 7x's, and that's still less than or equal to 21. Okay, and then I can use opposite operations. This is multiplication. The opposite of multiplication is division. And in this case, I'm going to divide both sides by 7. That gives me x. And since I'm not dividing by a negative, I do not flip the inequality sign. It's fine, just as it is less than or equal to 3. That is my solution. I'm not done though. I have to remember to graph it on a number line. So there's my number line. There's 0. There's 3. It's less than or equal to, so that's a closed circle. And if it's less than, I want to make sure that I shade to the left. Okay? So combining like terms. Once all your like terms are combined, then you just use opposite operations like we have been practicing in class to solve the equation. Let's look at another one. This is the distributive property. Okay, so I need to make sure that I multiply each term inside the parentheses by the term on the outside of the parentheses before I solve. Okay, so 1/2 times 10, that's the same as dividing by 2, right? So 1/2 times 10 is 5, and 5 is still being multiplied by y, plus 1/2 times 4, the same as dividing by 2, so that's 2, is greater than 17. Okay, so now I go in the reverse of order of operations. So I'm going to undo this part first. The opposite of addition is subtraction. So subtract 2 from both sides. That's a 0, so I have 5y is greater than 17 minus 2 is 15. The opposite of multiplication is division. And again, I am not dividing by a negative, so I do not need to flip my inequality sign. And I get, I'm going to put it over here, y is greater than 15 divided by 5 is 3. All right, and then on your number line, of course, here's 0, here's 3. This time it is an open circle, and I'm looking for greater than, so I shade to the right. All right, here's an example where I've got a variable on both sides of the equal sign. And of the inequality sign, excuse me. And it doesn't matter which side my variable is on or not on, but when I'm dealing with an inequality, I really like my variables on the left because it makes it much easier to graph my solution. So I'm going to move my m's to this side and my constant terms to this side because that'll make it much easier to graph in the end. It's one extra step, but it's easier in the end. So I'm going to subtract m from both sides. Okay, so over here, that leaves me with 0, which I don't really want necessarily. 2m's minus m is just 1m, and I can write that as an m, and then I still have my minus 6. Okay, so I want m by itself. So now the opposite of subtraction is addition. So I'm going to add 6 to both sides. And I've got m is less than 6. And even though I could have done it differently and moved my 2 m's here, and then I wouldn't have had to do anything with my 6, by doing it this way and getting my variables on the left-hand side of the equation, this is now much easier to graph on a number line. So I've got 0, 6, open circle, and I want less than 6, so I go that direction. All right, one more example. Okay, so this one's probably the most complicated. I've got variables on both sides. I've got constant terms on both sides. So again, especially with inequalities, I like my variables to be on the left and everything else to be on the right. So the first thing I'm going to do is subtract 9y from both sides. That gives me 0. I'm left with negative 15 over here. Don't forget that that operation sign stays with the 15. 12y's minus 9y's 3y and plus 3. Okay, so now the opposite of addition is subtraction. All right, so that's a 0. I'm left with 3y is less than or equal to negative 15 minus 3 is negative 18. Think of a number line. If you're subtracting 3, you're going farther to the left on the number line. You can also think of it as adding the opposite. Okay, so either way, you're going to get negative 18. Now my last step, the opposite of multiplication is division. So I have y is less than or equal to. Now I did not divide by a negative, so my inequality does not flip. And a negative 18 divided by 3 is a negative 6. So you were lucky in all of those examples. You didn't have to flip your inequality, but you should still check every time you're dividing. If it's positive, I don't flip it. If it's negative, I have to flip the direction of that inequality. Now I need to graph. Here's 0, negative 6 is over here. It's less than or equal, so it's a closed circle. And if I want less than, I'm going to shade to the left. Okay, that's your last example. Please remember to put in your guiding questions and your summary statement on your Cornell notes, and I'll see you in class.